today's mini class on the DICOM standard. Let's start with the obvious. DICOM stands for Digital Imaging and Communications in Medicine. And contrary to popular belief, it is not just the file type. Ultimately, the simplest way to explain it is that DICOM is the standard that tells medical imaging devices how to describe, exchange, store, retrieve, and display imaging information. And yes, it is commonly thought of as a file type because that's what really sits on the surface of it. But while that's not incorrect, it's only partly true. A DICOM file can contain an image and its medical metadata for sure, but DICOM itself is a much bigger domain than just a file format. So what is it then? It's a communication standard, a workflow standard, a display standard, and a data encoding standard for many types of imaging information. Think of it as a set of rules that devices can follow. These rules for communication are a really big deal, and one of the biggest reasons for DICOM existence is what we call interoperability. Think about it this way. CT scanner from one manufacturer, a PACS from another manufacturer, a workstation from another vendor, and then maybe a reporting system from somewhere else. They all need to exchange imaging information. And DICOM provides just that. It provides a common set of rules so those systems can communicate. Without a standard like DICOM, each vendor would create their own private way of sending images, which would make hospitals heavily dependent on that one vendor. In fact, we saw that in the early days of digitization, and that didn't work too good. DICOM, though, helps reduce what we call vendor lock-in, because hospitals can choose equipment from different manufacturers as long as those systems support compatible DICOM services and configuration. So an important practical point. DICOM does not mean every device automatically works perfectly with every device. The systems still need to be configured correctly, and they still need to support the same DICOM functions. But DICOM gives everybody the shared language. When people think of DICOM, they often think of X-ray, CT, MRI, or ultrasound image. But in DICOM, the image is only part of the story. A DICOM object, as we call DICOM files, may include, well, the image itself. That's pretty obvious. It should include the patient information. We definitely want that. Study and series information, very important. Modality information, in other words, what was the actual acquisition device? What modality type was it? Acquisition details, of course. Very important. Image orientation and positioning. How do you properly display the image? Very important. Display-related information, and then, of course, things like measurements, annotations, reports, or structured clinical data. So DICOM is not just a picture. It's a medical imaging object with clinical context. DICOM also governs how imaging systems connect to each other over the network. It defines various services. For example, storage, which is effectively sending images or objects from one system to another. Query retrieve, as the name suggests, searching for studies and retrieving them. Modality worklist, very big one, giving the modality the correct patient order information so that the technologists don't have to enter this manually. And then things like storage commitment or modality performed procedure steps, which are services that support various workflows. Things like confirming that the receiving system has safely stored the images or allowing the modality to communicate the procedure progress or completion information. You don't need to memorize every single service at the beginning. The key concept is this. DICOM is not just the object being sent. DICOM also defines the conversations between systems. For example, a modality does not just create an image. It may ask for a work list, acquire the images, send them to PACS, confirm that PACS stored them, and communicate that the procedure was performed. Those are workflow supporting functions, and DICOM provides services for them as well. DICOM can also store information that is not the original acquired images. Yes, I know this sounds a little counterintuitive, but stay with me for a sec. To give you an example of what those can be, DICOM can support objects that contain image annotations, presentation states, display preferences, measurements, segmentations, key images, significant images that were marked by a radiologist, derived or processed images, A very important idea here is that sometimes you do not want to permanently alter the original image. Instead, you may want to save instructions about how the image should be displayed. For example, show this image with this window level, this zoom, this rotation, and these annotations. That type of information can be stored in DICOM so another system can reproduce the intended display. Another major area of DICOM is structured reporting, often referred to as DICOM SR. This is how DICOM can encode measurements, observations, and clinical findings in a structured way. A good example is obstetrical ultrasound. The ultrasound images are important, but they only tell part of the story. The other part is the measurements: fetal measurements, gestational age calculations, anatomy measurements, Doppler measurements, other structured observations. Those are absolutely key, and those measurements can be encoded as a DICOM structure report and stored together with the images. This matters because the measurements are not just random text. They can be encoded in a structured, standardized way, so the other systems can store, display, process, and potentially reuse them. DICOM also deals with image display. DICOM even includes standards for how images should be displayed, which is very significant because, of course, we are dealing with medical images and we want to present them in a standardized way. Ultimately, medical imaging, of course, is not like regular photography. We appreciate that subtle differences in brightness and contrast can make a very big clinical impact. DICOM includes display calibration concepts, such as what we call grayscale display function, which is a curve used to calibrate medical monitors. And again, the goal is consistency. An image should not look dramatically different just because it is displayed on a different diagnostic workstation or medical grade monitor. Lastly, DICOM includes security-related components. Modern imaging systems need to protect patient information while allowing images to move between systems. That's a bit of a tall order, but that is where security comes into play. DICOM includes support for secure communications and security profiles, often used together with broader healthcare security practices. The key point here is this: DICOM is not only about moving images, it also has to support safe, controlled, and secure exchange of medical imaging information. As our core takeaway, most important message is this: DICOM is the common language of medical imaging. It defines how imaging data is packaged, how devices communicate, how images and metadata are stored, how studies are queried and retrieved, how workflow steps are supported, how measurements and reports are encoded, how images can be displayed consistently, and how imaging communication can be secure. So yes, DICOM can be a file, but more importantly, DICOM is the rulebook that allows medical imaging systems to work together.